So in this video and the next couple of videos, I'm going to do some truth table argument problems. So I want to just remind you of the method that we're going to use. So the basic idea is that an argument is valid if all of the rows are okay. It's invalid if there's at least one bad row. So we're going to be looking at the rows of the argument to determine are they okay or are they bad. And we'll just go through all the rows. And if in doing that, once we find a bad row, if we do, we'll stop, concluding that the argument is invalid. Or if we go through all the rows and they all turn out okay, then we'll conclude, aha, the argument is valid. And we'll remember that what is an okay row like? Well, there are two ways to be an okay row. One is your conclusion is true. The other is at least one of your premises is false. If either or both of those conditions are met, then the row is okay. They don't both have to be met. It's okay if either conclusion is true or the premise is false. On a bad row, on the other hand, is the opposite of an okay row. So for a row to be bad, the row has to have all of its premises be true and the conclusion has to be false. So we're looking, are there any bad rows or are all the rows okay? If we find a bad row, if we find a row with true premises and false conclusion, then we stop because it's bad. If we find that each row has either a true conclusion or a false premise and all the rows are okay, the argument is valid and we're done. So one of those two things is going to happen. So here's our first argument. The conclusion is simple. It's just the letter Y. The second premise is the conditional R arrow P, and the first premise is the conjunction of if P then Y with R. So we look at the truth table here, the values for all the different letters that occur in the argument, and here's the column for the first premise, here's the column for the second premise, here's the column for the conclusion. And nicely, the column for the conclusion is already filled out because the conclusion is just a letter Y, and so there are no calculations to be done. So if we remember, we're checking each row to see is it okay or not. If all the rows are okay, the argument is valid. If we find a bad row, that means the argument is invalid and we can stop at that point. So let's take a look at our rows and see what information we already have. So we look at row 1 and we see, aha, the conclusion here is true. It's already been filled out, and that means this row is already okay, because we know if a row has a true conclusion, it's okay. For a row to be bad, it has to have true premises and a false conclusion. Well, this already doesn't have a false conclusion. The conclusion is true. So all the rows on which Y is true, this row, no, not this row, and that row, so the first row, the second row, the fifth row, and the sixth row, on all of those, we know, well, the conclusion is true, and so on all of those, or each of those rows is okay. So we don't need to do anything more with those. What we need to look at are the third row, the fourth row, the seventh row, and the eighth row, and figure out if any of those are bad, or if all of those are okay. We know this row is okay, this row is okay, this row is okay, this row is okay. We look at these rows, we don't know whether the third and fourth, for example, we don't know whether or not they're okay or not. If this row has a false premise, then it's okay. If both of the premises are true, then it's bad. So right now we don't know, because we don't know whether or not the premises are going to come out true or false. So that's what we need to find out. We need to check for each row, does it have any false premises, in which case it's okay, or are all of its premises true, in which case it's bad. So the easiest way to do this is to calculate the values for the simpler sentences first. So this, if we look at this one, this is simpler, right? Why? There's only one connective. This has two. So if we look at the tree for, let's say, the second premise on this row, we see, oh, this is a short tree. It doesn't go very deep. But if we look at the tree for the first premise, oh, this is a bigger tree. That's going to be harder to do. It's going to take longer. We want to do this as efficiently as possible. So let's look first at the conditionals, or the conditional column, and calculate the value for the conditional on this row, this row, this row, and this row. Again, not worrying about the first and second and fifth and sixth rows, because we already know that those are okay. So here we are. We're going to do premise 2 on the third row. So we see it's a conditional, has a true antecedent and a true consequent, so it's a true conditional. Okay, now this could turn out to be a bad row. So maybe we could look at this, we could find out, we have two options. We know, okay, this row might be bad or it might be okay still, right? If that had turned out false, we would have known the row is okay. Right now we know maybe it's bad, maybe it's okay. If it turns out to be bad, then we're done with the whole problem. We don't have to do anything more, because once we find one bad row, we know the argument is invalid. So let's look at this cell, because if it turns out to be true, then we'll have true, true, false, and the row will be bad and we'll be done and we won't have to do any more. So that would be nice. So let's take a look at this. So we have, here we have the conditional P arrow Y. That's true arrow false. That means this is false. This is a conjunction, so we have false and true. That means it's false. A conjunction with a false conjunct is false. So this is false, true, false, and oh, that means this row is okay. So we don't yet know whether or not the whole argument is valid. We have to keep going. So that was too bad. If this had turned out to be true, then this row would have been bad and we would have been done. But it didn't. But okay, so let's go back to premise 2 and continue working down. So we have if false, then true. It's true. Maybe since this is so easy to calculate, let's just keep going. So here we have if true, then false. That's false. And if false, then false, that's true. Okay. So this row we now know is okay because premise 2 is false on this row. So on this row, there's a false premise, and so this row is okay. So we know this row is okay because that is a true conclusion. This row is okay because it has a true conclusion. This row is okay because it has a false premise. This row is okay because it has a true conclusion. This row is okay because it has a true conclusion. And this row is okay because it has a false premise. So the only two rows that now we look at this row, and we don't know if they're bad or okay yet. They might be bad, either of them. They might both be okay. If this is true, then this row is going to be bad. If it's false, then this row is okay. Same here. If this is false, then the row has a false premise and the row is okay. But if this is true, then both the premises are true and the conclusion is false, and so the row is bad. So we now need to look at these two cells and find out, is it true or is it false in those cells. So here we have, oh, well, look, we notice that the R is false. This is a conjunction. If a conjunction has a false conjunct, the whole thing is false. We don't even care about the truth value of the conditional because we know that R is false, and so we know P arrow Y and R is false already without worrying about the truth value for this conditional. Okay, so this row has a false premise, so this is an okay row. So let's go to this row and check out this one. Oh, look, again, R is false, so we know the conjunction is false without caring about the truth value of the conditional. So that means every row is okay. On this row and this row and this row and this row, we have a true conclusion. On this row, this row, this row, and this row, we have a false premise. False premise, false premise, false premise, false premise. So every row is either a true conclusion or a false premise, so every row is okay, and that means that the argument is valid. Let's check that, and it is. So what we're doing is just going through and looking, do we find any bad rows, or do all the rows come out okay? And we try to do so when we do that search, we try to do so in the most efficient way. So in particular, we focus mostly on, well, once you know that if you know a row is okay, you don't need to fill out all the cells on it. And then in deciding which cells to fill in, we go to do the simple sentences first, and then we only do complex sentences where we have to. So I'm just going to demonstrate this technique on 2 more problems in the next 2 videos.